virtual STEMmy students. And hello to everybody in Sonia and Hoffman's class. My first launch video, they finally trust me enough to create a launch video. Hopefully I won't mess up. We're going to be talking about today, Wednesday's lesson, which is 5.20.20, identifying heat transfer. Now, you guys have just spent the last 3 days, I believe, 4 days, learning how heat transfers. To review, we know it always transfers from a hot surface to a cold surface, from hot to cold. That's the way that it moves. And we learned that it moves in 3 ways. It moves through radiation or radiating. It moves by conduction, where thermal energy transfers from one surface to another. Like we put our hands together, I grab my coffee cup, and the thermal energy is transferred through the hot coffee, through the cup, and then into my hands. Then we talked about convection. Now, convection, when we talk about convection, we're only talking about liquids, or the invisible liquid that's all around us, air, our atmosphere. In those circumstances, heat transfers through something called convection, because as those molecules get heated up by whatever source, they move apart, they get less dense, they go up, and then as they go up, they push the cooler particles down that get heated, and then these eventually cool and come down, and you've got this whole convection current. And that is how the heat dissipates throughout the water or the air. And it's going on in our air. We can't see it so much, although we can feel it when we're talking about wind. That's what we're talking about. It's created by the uneven heating and cooling of our Earth. So anyways, your job. And I'll just read the directions. So now that you have had lessons on the following forms of heat transfer: conduction, convection, and radiation, your job is to describe the 3 forms of energy transfer in the following pictures. The first one's done for you and should serve as an example for you to follow. Okay, so radiation, the thermal energy from the gas flame, is being radiated or transmitted in the form of waves or particles away from the flame in all directions. Okay, you can see that from the picture here. Those arrows are the thermal energy moving away in the form of radiation. Then you have conduction, the transfer of the thermal energy from the metal pot to the water and to the handle by direct contact. Okay, the thermal energy is radiating to the surface of the kettle, which is then transferring that thermal energy into its particles and then into the particles of the water. And once the water starts heating up, molecules move apart, they rise up, they cool down, they go down, and we've got this convection current. All right, like I said, it also happens in the air. So now I've got a series of pictures here. The first one, I believe, was in that con video. So this should be relatively easy. You got people roasting marshmallows around the open flame. If you've ever done marshmallows, you really don't stick them right into the flame. You kind of hold them the way, at least I like to do that. You hold them away and you just let them get nice and golden brown. Some of you like it black and you'll let it catch on fire, and that's all good for you. So I would like you to explain in this picture radiation. Where's the thermal energy radiating? Where is it conducting? And is there any convection taking place? Do we have any air or any water available? I wonder. And by the way, those handles that they're using, those are made out of steel. I have a set of those just like that at home. And yeah, you should be able to do a good job on that one. Now, this one, I'm kind of thinking that you could do all 3 on this one as well. You'd have to describe, this is a beach, that's actually at the ocean. So you got to talk about there's radiation, if there's thermal energy in a form of radiation, is there anything conducting this thermal energy? And then is there any convection taking place? All right, next one is a solar cooker. You know, we gave you that challenge on the solar cooker, and to date, I think only one person made one. Well, except for me and Sonia. So, is there radiation involved in a solar cooker? Is there conduction? Now, there's a metal pot that is sitting down inside that box. We've got aluminum foil all around it, and there's a glass top over the top of that. And is there any convection that takes place in this setup? You know, it does say, please complete at least one of 3 ways that energy transfers to the image. If you're like stuck, like, I just don't know what I can't think of more than one. Well, then, if you can nail conduction, then write down where the conduction is happening. Now, this one here, this is actually the system that I have at my house because I have an above ground pool, and that is a solar heater. I'll just explain how it works, but you guys got to tell me where the radiation, conduction, and or convection is taking place. This is I'll put my cursor down here. I'm circling, that is the filter, but that little black thing on the bottom is a pump. And what it does is it takes the water from the pool, pumps it through the filter to clean it, and then it goes into this solar heater. Now the solar heater is like hundreds of little tiny tubes. We're really talking little here. Almost like they're smaller than a straw that you would suck out of. And there's hundreds of them, and they go back and forth. So the water goes whipping through all of those tubes, and then it shoots back into the pool. Now that's all I'm going to tell you for that one. You've got to figure out how the thermal energy is being transferred in that situation. But really, all 3 are available here. And then the last one, that is an infrared heater. Okay, there's like a gas that gets heated up in there, and then it gets hot, and it pushes out the thermal energy. When I worked in the auto body repair shop, we had those on the ceiling, and it was really cool because you feel no air blowing on you or anything. It's just, I don't even want to say the word because I'll give it away. But anyways, the person looks like they're warming up their hands with that heater. This should be a no-brainer too. Tomorrow then, I plan on making an answer key video, and I'll work my way through these and have this all filled out for you. And in case you're like super stuck, you can take a look at that. Alrighty then, have a great Wednesday and rock this. I know you can rock it.